All right, so here we are, the last lesson of the semester. So we're going to be talking about Chapter 12, Section 1, which deals with just simple linear regression. All right, and I got just a bunch of notes here listed. So remember, you can always just pause the video and then write them down and listen to what I got to say. But we're going to be talking about regression lines. Now, regression lines have this form where it's called a deterministic model initially. So, for example, this is going to be y equals alpha plus beta times x. And normally, what we use as our model will be y equals a plus bx. All right. Now, we've seen this before in algebra class. This is nothing more than just the equation of a line, which we're going to review some of the characteristics of a line. But the whole thing behind this regression line is that we can use them to predict values. Okay, so maybe we're interested in a relationship between two variables, and when we plot them, it kind of looks like a line or something like that, and we can use that information to start to predict things. So to do this, we start by assuming a linear relationship exists. Now, this linear relationship is going to exist between x and y. Now, x, if you recall from algebra, is called the independent variable. All right. Well, when we talk about deterministic models, the x variable is called the predictor variable, and y is our dependent variable or the response variable. So in other words, the x is the variable that will predict things in y. Okay. So, if you think about it, you got this Cartesian coordinate plane, or another name for that is a rectangular grid. X is going to be the independent variable, it's the horizontal axis. Y is going to be the dependent variable, the y-axis. And recall that if we have a line, all we need are basically 2 points to form that line. And then we can go ahead and make generalizations about stuff like this. Okay? Now, the key to this is that when we plot these data points, what we really want to look at is the line, or the line itself determines the values between the predictor and the response variables, provided the line is a good fit. Now, what we mean by a good fit is we may run into the situation here where we have these data points right here, something like this, and this is going to be very specific. All right. Now, notice this is what we call a scatter plot, and we focused on scatter plots all the way back in chapter 1. All right. So this is a scatter plot. Let me write that a little cleaner. There we go. And we really can't write an equation of a line because our data points here are just they're scattered. They're not in a nice straight line as the example above. But what we could do is create what we call a regression line. All right. So this is going to be that line alpha, plus beta x. And what this line does for us is it gives us a best fit for all the data that we've looked at. Now, in the next example, we're going to be looking at a probabilistic model where what we do, and I'm going to zoom in here, is we focus on the distance. You know what? Let me just draw a line. This distance right here is what we call some error. All right, we abbreviate with that weird looking E. Another way to write it, I guess, sometimes books will just use E. I'll just leave it as E. That's fine with me. Okay? But this best fit line, what it's designed to do is it's designed to minimize every single one of these points, the distance away from the line. Okay? That's the goal. That is the goal of a best fit line. It minimizes all the differences, or the difference between the point and the line itself. Okay? But more on that later. What I want to go over right now is let's kind of review from algebra, like lines and stuff like that. Okay? So from algebra, we know that we have y equals a plus bx. Now, a is going to be the y-intercept, and it always has this value, or this point, 0, a. And b is our slope, which we interpreted as the unit rate, which is a change in y for a 1 unit change in x. And that's the key. See, I know a lot of us, and it all depends on really what math professor you've had back, in the past. For me, when I go over teaching slope, I make sure I go over what the slope actually represents. Because I know a lot of us, when you think of the word slope, you may think of rise over run, which is 50% of the truth, all right? Slope is a unit rate. It measures the change in y over a measure of the change in x, okay? So I know that if x changes, y is going to change, and it also tells me how fast that is occurring. And it tells me if it's increasing or decreasing. So a little example I have here is, let's talk about making ice cream, okay? So we know when we make ice cream, we incur cost. So when we make this ice cream, notice here, I have the slope. Now, how do I know it's a slope? Well, it's a fraction, and I got a change in y over a change in x. So my change in y is 25 cents. My change in x is 1 unit. So to interpret this, I know that for each additional unit of ice cream that I make, it's going to cost us 25 cents of an increase in cost. So that is what slope is. It's a change in y with respect to x. All right? Now, if you remember to graph a line, all right, graphing lines are very simple. A lot of people will go ahead and they'll write like the XY chart, all right, and they'll try to make all these points. Well, I don't really do any of that, because if you know that you have a line, which we have right here, and this line is what we call slope-intercept form, all we have to do is plot the y-intercept. So we're going to plot the y-intercept. So in this case, it's going to be 0, -3. So that's all the way down here. I'll label it for us. And then step 2 is we use the slope to determine the next point. So since my slope is 2 over 1, I know I'm going to go up 2 units. So 1, 2 units, and then to the right 1 unit, which is right here. And I just connect the dots. Okay? And that's how I graph my line very quickly. Now, the thing you got to remember here is this. All right? I'm going to just scroll over here. If this is our line right here, let's say -3 over 2x plus 1. Okay? So if you just give me a second here, just catch up. So if this is our equation of a line, remember, we plot the y-intercept first. So the y-intercept is 0, 1, that's right here. Okay? And then part 2, or step 2, our slope is -3 over 2. Now I know, and I said this earlier, and I said it's only 50% correct. A lot of us think of slope as rise over run, and that is just wrong. It's not only rise over run. Slope can be fall over run as well. So let me write that here. Slope is rise or fall over run. And the key to this is that when we run, you always move to the right. Always. All right? So if I want to plot y equals -3 over 2x plus 1, I plot the y-intercept first. My slope is negative. Therefore, for step 2, I'm going to go down 3 units, and I move to the right 2 units. So here's 1, 2, 3 units, and then to the right, 1, 2 units. And there's my next point right there. Now, I will connect the dots. Okay? So now what I wanted to do is, now that we kind of reviewed a little bit of the algebra and we know regression lines allow us to predict values, and we have a predictor and a response variable, and we know the predictor variable is the independent variable, it's x, the response variable is the dependent variable, and that's y. I want us to consider this example right here. So this deals with hours of sunshine and ice cream. So John found how many hours of sunshine versus how many ice cream sandwiches were sold. Now, if you think about this, this is a very nice, simple example that deals with business. And what's happening here is, we know that when it's nice and sunny outside, it's hot, we would expect to sell more ice cream. But the problem becomes, I need to make sure that I don't buy too much ice cream, and I don't want to buy too little of ice cream, because I want to make sure I got enough ice cream to support the number of sunny days that I have, because I don't want to throw away unused ice cream that expires, but I also want to make sure I got enough for my customers. So I kind of just collected some data, and I found that when there were 2 hours of sunshine, I sold 4 ice cream sandwiches. When there were 3 hours of sunshine, I sold 5 ice cream sandwiches. When there were 5 hours of sunshine, I sold 7 ice cream sandwiches, and so forth, okay? So what I did is I went ahead and I plotted these values for us, and I'm going to show you what that looks like right now. All right, sorry about that. I had to clean this graph up a little bit here. I didn't realize it looked that small on the screen. Let's see if I can make this a little bit bigger now so we can all see this. All right, so you should be able to see this pretty well. So here's a scatter plot. Now, remember, the hours of sunshine is going to be our x variable. The ice cream sold is our y variable. So we have those axes respectively here, okay? And let me get rid of this. There we go. And if you look at these points, they kind of look like a straight line, but they're really not. If I just change this to just this little guy right here, get rid of this behind, notice that it almost looks like a straight line, but it has this like curve to it, okay? So a straight line model would not be appropriate here, because remember, a straight line means that the points fall on that line. But what I could do with this is I can take this one step further. I can say, well, since this isn't a straight line, maybe I can make a best fit line for this, okay? Now, to show you what I'm talking about, what I'm going to do first is I'm going to change what type of graph this is. I just want to make this just a basic scatter plot. All right? And then I'm going to add this line right here. And that is what we call our regression line. This is our best fit line, okay? And I'm going to show you not only how to create this line, but how to calculate it as well. And as you can see, and I'm going to zoom in here for us. Here we go. You can see that this line basically flows through all the data values, and it has what we call a linear trend to it. So if you look at these data values, if you look from left to right, you can kind of see that they go from bottom left to top right, and they kind of form a straight line. It's not perfect, but it's almost a straight line. And that is so important for us, because if you remember, one of the assumptions that we make when we're talking about a simple linear regression is the fact that there is a relationship between the x and the y variables. Now, the only way that you can demonstrate that there's a relationship is if you notice that they have this straight line pattern going from left to right, okay? Now, I'm using Excel for this example, but I'm also going to show you this in Salt as well, because Salt, the reason why I chose Excel is because I can zoom in on the graph like this, and I really can't do that with Salt that well. So, if I'm looking at Salt, let me see if I can find it right here. Oh, geez, I got to find it. All right, so here's Salt, and like I said, it really doesn't look that great. It doesn't look nowhere near as good as what the Excel one looks. But you can see right here that we have all of our data points, and if I click this box right here that says regression line, I get that line again, okay? And most importantly, if I just scroll down, I'm going to zoom in and scroll down. Notice, here's our information that we need right here. We got our slope, and we got our, excuse me, y-intercept. Now, I'm going to show you how to generate these numbers, okay? The method that we're going to be using, let me go back to our notes. So the method of least squares. Okay? Now, earlier I mentioned that we're going to be looking at not a probabilistic model. So the probabilistic model looks like this. So we have y equals alpha plus beta x plus some associated error. And this is a very simplified version again. So right here is going to be our regression line. And what this regression line does is the goal is to minimize the sum of all the associated errors. All right? And an easy way to do that is just by drawing rectangles or squares. Hence the phrase, or hence the method, least squares regression. Okay? Now, there are some assumptions that we make about the random error. All right, which is this weird looking E. All right, the first assumption. Let me just write the sentence. I'll write it like this so I don't have to write it 8 times. Or, sorry, 3 times. The values of E are assumed to satisfy the first. They're all independent. Two, they have a mean of 0 and a common variance, which is just a variance, equal to the population variance. And 3, they follow a normal probability distribution, meaning that, and it's going to be kind of hard for me to draw because I'm not an artist. I wish I had somebody standing right next to me that is an artist. Meaning that if I were to do a normal curve, they kind of all flow through that normal curve. If I were to just plot each one of these and try to find its value for x1, x2, and x3 respectively. So now what we can do is we can formally identify the principle of least squares. So I'm going to pause the video, write down the definition, then I'll unpause it. All right, so here's our definition of principle of least squares. So the line that minimizes the sum of squares of the deviations of the observed values of y from those predicted is called the best fit line. Now that is a big sentence for once you create your scatter plot, the principle of least squares will create a line that minimizes the difference between the error and the actual line itself, okay? So an easy way to think about this, and I'll finish reading the rest of the definition. The easy way to think about this is pretend that you have a scatter plot and you have a ruler in your hand and you're sliding that ruler. If you were to draw, or if you were to try to minimize the distance of all these data points right there, you might get a line that looks something like that, okay? This is, like I said, for like the 10th time already, this is our best fit line. So this is the line that minimizes the sum of the deviations of the observed values of y from those predicted, okay? Now, the sum of squared deviations is commonly referred to as the sum of squares error, or SSE. Now, what we can do here is we define this as SSE equals the summation of yi minus y hat I squared, which is equal to the summation of yi minus a minus bxi squared. So before we get really nervous about this, okay? Right there, you can kind of think of that as your predictor equation, the y equals a plus bx, okay? So what we're going to do is this. We're going to take this information and we're going to estimate alpha and beta, because remember, our regression line is y equals alpha plus beta x. But what we are going to do is we're going to estimate what these values should be by using a and b respectively. Now, I will say this, okay? If you got a calculator or if you want to use SALT, I suggest it only because it makes all this calculating so much easier, okay? So first things first. The line that we're looking for is going to be y equals a plus bx, okay? Now, the location of these of the coefficients a and b are extremely important. That's first. So make sure y equals a plus bx. Second, b is going to be defined as the sum of the cross products. Now, the sum of the cross products is right here. This is the sum of cross products divided by the sum of squares. All right? So SXY is the sum of cross products. SXX is the sum of squares. So that's how we find B. A, which is our y-intercept, equals the average of the y values minus B times the average of the x values. So in order for you to calculate A, you got to do B first. So we find our slope first, and then we find our y-intercept second. Now, to find the sum of the cross products, there are different formulas that exist. I find this one to be the easiest. So the cross products will equal the summation of xi yi minus the summation xi times the summation yi all over n. What this is saying here is this. Take all of your x and y values, multiply them, and then add them up. Subtract that from all of your x values, add it up, all of your y values, add it up, and multiply that value and divide it by n. And the summation of squares is going to equal the summation, or the sum of squares, is going to equal the summation of xi squared, or all your x values squared, minus all of your x values added up and then squared divided by n. I know it's a lot. So what I'm going to do is I'm going to do this by hand, and I'm going to show you how to do this. Okay? Okay, so here's the example we're going to use. We're going to use the ice cream data again, and we're going to find the cross products, and we're going to find the sum of squares. Okay? I don't know which one you want to do first. I'm going to do the sum of squares first because that formula is a little bit smaller. Okay? So if we look at the formula, so let me zoom out here. And let me see here. It's going to be equals. I'm just going to rewrite the formula. All right, there we go. So we got our formula. Ooh, let's move this down a little bit. It's going to get in my way. Here we go. All right, so if we look at this formula, we need to find all the x squared values first and add them up. So I'm going to create a new table, or not a new table. I'm going to create a new column, and I'm going to write x squared. Now I'm going to square all of my x values. 2 squared is 4. 3 squared is 9. 5 squared is 25. 7 squared is 49. And then 9 squared is 81. Now, I'm going to take all these values. Let me write it over here. I'll put totals. And I'm going to total it all up, okay? So, when you add 4 plus 9 plus 25 plus 49 plus 81, you get 168. So far in my formula, for the sum of squares, I have 168 minus. Now, the fraction that we see, that tells me add up all of the x values and square it. So I need to add up all of my x values and then take that result and square it. So 2 plus 3 plus 5 plus 7 plus 9 is going to be 26. So this is going to be 26 to the second power. All divided by n, which is going to be the number of samples that I have here. So this is going to be 1, 2, 3, 4, 5. So I need to divide this by 5. So the sum of squares is going to equal 168 minus 26 to the second power divided by 5. And that's going to give me, sorry, I'm using my calculator here. That's going to give me 32.8. All right. So I know the formula looked bad, but when you think about it, it's really not all that bad. It's just a matter of just keeping everything organized. Tables will be your best friend here. All right. Now let's go ahead and we're going to do the cross product. Now the cross product, more involved in that formula, but that's okay. All right. So all I did here is I just erased everything and I wrote in the upper right hand corner of your screen the summation of squares. All right. So now we're going to do summation of the cross product. So we have the formula here. And notice that what we need to do for the very first, I'm going to go left to right, is we need to sum up x times y. So I need another column here of x times y. So what I need to do is take 2 times 4, which is 8, 3 times 5, which is 15, 5 times 7 is 35, 7 times 10 is 70, and 9 times 15 is 135. And then I'm just going to add all them up. So I get 8 plus 15 plus 35 plus 70 plus 135 to give me 263. So that number goes right here. Minus, now I'm going to add up all my xi's. But I already did that. So that's going to be 26 times, but I need to add up all my y values as well. So 4 plus 5 plus 7 plus 10 plus 15 is 41. And then I just divide all of this by 5 again, because that's how many data points I have. I have 5 of them total. So when I go in and do this, the summation of my cross products is going to be 263 minus 26 times 41 divided by 5, and that gives me 49.8. So my cross products is going to be 49.8. Okay? So once again, the math it's not difficult. It's just very tedious and very involved. You just got to take your time with it. That's it. So now that we have our sum of squares and the sum of the cross products, And I'm just going to write them down again. So the sum of squares was 32.8. And the sum of cross products was 49.8. We can take the next step here, and what we can do is we can find our regression equation right here. Okay? So we know, and I'm going to scroll up here real fast because I need to copy and paste some stuff. So we know that we got to find B first, and then we use that information along with the means of each to find A. So I'm just going to copy this, drag it down, and I'm going to copy part 2. The second part, I just don't want that number 2 in there. And we're going to copy this as well. All right. Oops. Don't know what happened there. All right. There we go. So remember, calculate B first, then calculate A. So B, which is our slope, is going to be 49.8 divided by 32.8. So when I take 49.8 divided by 32.8, I get 1.518, and we'll round it to 4 decimal places. So there's B. Now I use B to help me find our y-intercept A. So A is going to equal, now notice we have y bar and x bar. So I'm going to come back up into my table here. X bar is going to equal, remember, it's the summation of all your data values divided by the number you have. So X bar is going to be 26 divided by 5. So 26 divided by 5 is 5.2. And then Y bar is going to be 41 divided by 5. So 41 divided by 5 is 8.2. So 5.2 and 8.2. So A is going to equal 8.2 minus 1.5183 times 5.2. So A is going to equal 8.2 minus 1.5183 times 5.2, which gives me 0.30484. Okay? That's a lot. Now what we can do is we could say y equals 0.30484 plus 1.5183. And right here is what we just found to be our best fit line through our data values. So I can use this. Oh, I am being a very bad teacher right now because I forgot to put X. There we go. Now we're talking. So what I can do now is I can use this equation to actually help me to figure out, okay, if I have X equals, let's say, 5 days or 5 hours of sunshine, this will approximately tell me how many ice cream sandwiches I would need. All I would have to do is just say y equals 0.30484 plus 1.5183 times 5. So let's see here. So I'm just going to get out my calculator again. 0.30484 plus 1.5183 times 5. So if I use my calculator, I get y equals 7.89. So I would say 8 ice cream sandwiches is what I would need. Now, if we go back to our actual data values here, okay? I'm going to go all the way back up. Notice that for 5 hours of sunshine, the number of ice cream sandwiches I sold was 7. Our model predicted, scroll all the way back down, our model predicted approximately 8, which makes sense because you got to remember there's error associated with this model because our regression line, which I'm going to show you right now. All right, so using SALT, here's all my data values, here's my regression line. Notice that at 5, although we want 7 ice cream sandwiches, okay, that regression line is an estimation of what you would need. And if I just scroll down here, here's our summary. Notice that the slope is 1.5183. It's exactly what we calculated. And our intercept is 0.3049, which we calculated 0.3048. So we were off by, what is that, 1/10,000th of a number. So, we're not off at all. It's just, this is a regression model, and it estimates, and it tries to predict what we would need. Now, I think it's only fair for me to show you how to do this using SALT and how to do this using your calculator. So I'm going to do SALT first because it's by far the easier of the two. So you're going to need Excel or you're going to need Google Sheets or something like that. All right, let me scroll out here a little bit. All right, so the first thing you want to do is just go ahead and type in all of your data values. So remember, maybe I should have did this. X equals hours of sunshine and Y equals ice cream sold or ice cream sandwiches sold. Okay. If you want to use SALT, type it in, file, click on save as, and you want to save it as a CSV, which is a comma to delimited. I don't know if it's going to let me zoom in on that. It's not. So what you're going to have to do is click on here and then go down until you see the letters CSV, which stands for comma delimited. And then what you're going to do is just save that. What I would do personally is I'm just going to save this to my desktop so you can see it. So CSV, there it is. We'll go ahead and click on save. And then to use SALT, so you're gonna click on data set. You're gonna upload your data. So you would click upload CSV. Since I saved it to the desktop, right here it says ice cream versus sunshine. So I'm gonna just go ahead and double click on it, and it's gonna say, okay, tell me what variables you want. So I'm just gonna click on select all, and click select. Here are my data values. Now we go over to charts and graphs, because we want a scatter plot. Now we know our X variable would be hours of sunshine. Our Y variable would be ice cream sold. And it gives you just the standard scatter plot. If you want the regression line, which is what we do, we definitely want it. Click on regression line. It gives us this nice orange line. And then we just scroll down and it gives us our data values right here, our slope and y-intercept. The only thing you got to remember is where do they go? Remember, and I'm gonna go back to our notes here real quick. Our model is y equals a plus bx. This is our slope. This is our y-intercept. Now, you really don't have to worry about that too much. Okay, when you're using SALT or Excel, or I think even Google Sheets will do it as well. So you don't have to worry about it too much when you're using those technological tools, because they give you the words. They tell you, this is the slope, this is the y-intercept. All right. The weird part is when you come in and you use your calculator. So let me show you that real fast. So here's our calculator. Now remember, I like to use the TI-84. It's the one I'm used to. All right, so let's turn it on. So if you have your TI-84, definitely pause the video. Oh, you probably can't even see this right now. I am sorry. There you go. Now you can see the calculator and everything. So if you're using the TI-84, the TI-83, This will work if you're using like a TI-89 or a TI Inspire. I don't know how to do it on those calculators, but what I do know is YouTube, and I know how to type in how to do regression analysis on a TI-89. So you could figure it out that way. But for us, we were in stat class. So here's our stat button. So we're going to click on stat. And we want to go ahead and select the very first option, which is edit. We're going to click on edit. And it gives you these lists. So we're going to go ahead and we're going to type in our values. And we're going to use the X values first. So L1 represents the X values. So this is going to be 2, 3, 5, 7, and 9. All right. Then for list 2, to get there, we're going to hit the right arrow. And then list 2, we're going to type in all the Y values. So 4, 5, 7, 10, and 15. Okay? Once you have all your data values in there, you're going to click on Stat. You're going to go over to Calculate. And now this is where you need to be careful because we have 2 linear regressions. If you look at option number 4, it says linear regression AX plus B. We do not want that one because remember, our model is going to be A plus BX. So you have to go all the way down to option number 8 because this is our linear regression model that we want. Okay, they're going to both give you the same values. It's just with number 4 linear regression, it puts the A as your slope and the B as the Y-intercept. We don't want that. We want A plus BX. So we go all the way down to option number 8. We hit enter, and it's gonna ask us, where's your X list? Well, that was list 1, so it should already be there. Shouldn't have to change anything. Then it's gonna ask us, where's our Y list? Well, that's gonna be Y2. And all this other stuff, I really wouldn't worry about it at all. Just go ahead and just click down until calculate is highlighted. Hit enter. And here you go. So it's telling you, here's your regression model, Y equals A plus BX. A is our Y-intercept, which is 0.30487. If we rounded that to 4 decimal places, we would have 0.3049. And then B, which is our intercept, is 1.5183 if we were to round to 3 decimal places. Okay? And that's basically it in terms of how do you use technology to do this. The only thing I would suggest is if you don't have access to a calculator and you don't like using SALT, if you want to use Excel to find all this information, I say go for it. I think it's really good because what Excel allows us to do is it allows us to quickly add things up. So what I mean by that is this. I'm going to do that table that we had earlier to help us. So for the totals here, I would hit equals sum. Oh, sorry, screwed it up. I need parentheses. There we go. So now I'm just going to highlight what I need. So here's our sum 26. And like I said, what's beautiful about Excel is that once you type in the formula once, this row is going to always give us the totals for everything that we need. So I'm going to leave this here for now. Now, if you remember, and I'll go back in our notes real fast so you can see what I'm doing. I'm doing this table right here. All right. So notice I need the summate. I need the totals for X. I need the totals for Y. I need all the X squareds, and I need the X times Y column. So watch how easy this is that I'm going to show you how to do this using Excel. So I need the X squareds. So this column is going to be X squared. So I hit equals. I click on 2, or I'm sorry, I click on the cell that contains the number 2, and I just square that number. So I hit enter, and I know 2 squared is 4. Now watch this. If I just scroll this down, that gives me 4, 9, 25, 49, 81. I don't have to worry about using a calculator. I don't have to worry about mentally doing it because sometimes I can make a mistake. I let the computer do the thinking for me. Next, this is going to be the column X times Y. So I hit equals. I click on the cell that contains the 2. I hit the times button. I click on 4. Now I know 2 times 4 is 8. So I can scroll this down. So there's 8, 15, 35, 70, 135. And like I said, if you already did the sum row, just grab it and scroll it over, and it gives you all the sums. The only thing I like to do, because I'm very pet peevey about this, is I like to have everything nice and organized and bolted appropriately and everything. And then you can even take this one step further. You can say, well, I'm going to find B. So I'm just going to go ahead and just, sorry, like I said, I get really weird with this in terms of like how I like things to look. We know B is going to equal the summation of the x's, or the summation of the, I need to go back to our notes so you can see it, because I just don't want to read it off. All right, so here, so the sum of squares. Well, yeah, we got to do that one first, I guess. So the sum of squares is going to equal the summation of the x squared minus the summation of the x's, then you square it divided by n. So I'm just going to go ahead and do that for us. So sum of squares. And then over here, I'm just going to put equals. Now we need, oh, that's not even spelled right. I'll come back to it. So we need the summation of all the x squareds. Well, that number's right here. Minus, now we're going to put this in parentheses. Summation of all the x's squared divided by the number that we have, which is 5. So I just go ahead and hit enter, and there's my 32.8. Let me go and fix this spelling. Now we need the sum of cross products just move us over a little bit here. There we go. So if we go back and look at that formula, it's going to be the summation of, and I'm going to underline it here for us so you know what I'm talking about, summation of x times y. Then I add up each individual total for the x's and the y's, multiply them, and divide by 5 again. So we go back to Excel. I'm going to hit equals. Now here's our x times y column. There's our total. Minus. Now this one you got to be a little bit careful with, because we need to do x times the summation of x times the summation of y in the entire numerator. So I'm going to put that entire thing in parentheses. So here's the summation of the x times the summation of the y's and the parenthesis, now divided by 5. Okay, there's our 49.8 that we calculated. Now we can go ahead and say, all right, well, B, we know B is equal to the cross product divided by the sum of squares. So it's going to be this number divided by my sum of squares. So there's our 1.5183. We can just round that to 3 decimal places. There we go. And then A is going to equal. Now remember, that was A is equal to, and I'll go back to our notes so you can see it real quick. A is equal to y bar minus B times x bar. So I'm going to type in the average of y bar. So it's going to be all my y values minus B, which is right here. Oops. Times the average of all my x values. And there's our 0.3049. And we're on that to 3 decimal places. And the beautiful part about Excel is this. Let's say this 2 was actually incorrect. All right, for some reason you hit the button wrong. I don't know. say it's supposed to be 11. Watch what happens to all my numbers here. It's a beautiful thing. I hit 11. Everything automatically updates. That's why Excel is so powerful, because you can literally change one number and everything updates for you if you think about how you want to type all this stuff in. Personally, for me, I think this is what you need right here. It's just do this simple math using Excel or your calculator or Salt. That way you get it out of the way. Okay? So that's going to be it for this lecture video. I realize it's 50 minutes, but this is it. So good luck. If you have any questions, just email me. Other than that, fantastic semester. I'll see you on the final. Bye.